Good morning, students. So in few videos we studied the basic concepts involved in the coordinate geometry, and now it is the time for solving the problems using those concepts. Okay, let us move on to solving the problems. I will solve the exercise problems both in CBSE as well as Samacheer, but only few problems I will solve which are of direct substitution types. That means just substituting the values in the formula and finding the solution. So only few of such problems I will solve. What I will concentrate more is the problems which improve your higher order thinking skills. Let us concentrate more on that area, right? Okay. Before going to solving problems, there is one concept involved is finding the area. We will start with finding the area of triangle, then we will move on to finding area of quadrilateral, then we will solve the problems involved in these two topics, right? Area of triangle. You know formula for finding area of triangle. One is very simple formula. Suppose this is a triangle having height h and base. If these two values are given, then area of triangle, I am writing triangle this symbol, okay, for short form. Half into base into height, right? This is one formula for finding the area of triangle. The other form, another formula, this is another formula which is called Heron's formula. Heron's formula to find the area of triangle. What is S? A, B, C are the sides of triangle, the lengths of each sides. And what is S? S is nothing but A plus B plus C by 2. So if the lengths of three sides are given, then we can use Heron's formula. And if base and the height, okay, if these two information are available, we can use this formula to find the area of triangle. But in coordinate geometry, as I said earlier, we deal with coordinates, okay, finding the properties of various geometric figures using the associated coordinates, right? Let us see how to find the area of triangle if the three coordinates are given. If the three coordinates are given, right? Let us take a triangle. This is a triangle A, B, C. This is a triangle, and the coordinates are x1, y1, x2, y2, x3, y3. While drawing geometric figures, it is important to take the vertices in cyclic order, right? For triangle there is no problem writing A, B, C, but in quadrilateral, say this is a quadrilateral, you have to write either A, B, C, D or A, B, C, D in a cyclic manner, either in a clockwise or in an anti-clockwise. You should not write A, B, C, D. No, this is not allowed. Okay, this is not allowed. Before we move on to finding area of triangle, let us review one concept. Multiplication of algebraic terms, because this is useful while deriving the formula for the area of triangle. Okay, let us review it. You know distributive property, right? X into y plus z is equal to, using distributive property, what is that? xy plus xz. This is a basic distributive property of anything. Let us say 2 into 4 plus 6. What is that? 2 into 10, which is equal to 20. Similarly, using distributive property, 2 into 4 plus 2 into 6, right? 8 plus 12. This is also 20 and this is also 20. This is a simple distributive property. Here it is plus. If it is minus, simply it will come here minus. That's all, right? Suppose there is a multiplication of two algebraic terms, x1 plus x2 into y1 plus y2. Let us see how to multiply this. A method called FOIL is used. What is this? This is first term, first. This is outer, I. This is inner, this is last. That is, first you have to multiply first terms. What are the first term? This is the first term here and y1 is the first term here. So first we have to multiply this. Then outer. What is that outer? Outer means extreme. x1 is extreme. This first term as well as extreme. It is at extreme. Okay. So x1 here, y2. Y2 is at extreme. Then inner terms. So these two are inner terms. These first term and outer, this is inner, then last. Last, here in this term, x2 is the last, here y2 is the last. So last. This is how we have to multiply, and this method is called the FOIL method. So in that way, we have to multiply first terms. First x1 here and y1 is the first term here. So x1, y1, then plus. Let us put plus or minus. I am putting plus or minus. That means here it may be plus or it may be minus, whatever it is. So here also plus or minus. If it is minus, we have to put minus. If it is plus, we have to put plus. Okay. So let us say only plus. So x1, y1, outer terms plus x1, y2, then inner terms plus x2, y1, then last terms. Last term in each algebraic expression, x2, y2. So this is the way of multiplying two algebraic terms. So by using this, now we are going to derive the formula for area of triangle. Okay, this you should remember. So you mark the coordinates in a cyclic manner. Let us take this triangle and the coordinates are x1, y1, x2, y2, x3, y3 of the three vertices. Right? So the coordinates are given with respect to the axis x and y. So this is y1 and this is y2 and this is y3. It appears y2 and y3 are same, but I will draw this triangle just to distinguish between the various vertices, various coordinates A, B, and this is the x3, comma y3, right? And this is the point y3. Similarly, the x coordinate on the x-axis, this is x2 because B is here, A is x1, x3, right? So now let us draw thick lines. Let us draw perpendicular lines from the vertices to the x-axis, right? To the x-axis, and we will mark. We will assign some value A, B, C, and this is D, E, F, right? Okay. Now we need to find the area of triangle ABC. Okay. Before going to find the area of triangle, you must know the area of formula for area of trapezium. Okay. What is the area of, what is trapezium first of all? It is a quadrilateral to one pair of two opposite sides. Okay, one pair of opposite sides are parallel and the others are not. Okay, suppose if the length is A and this length is B and height is H. Height is between the parallel sides. Okay, then area of trapezium is equal to half into A plus B into height. That is the length of the parallel, sum of the lengths of parallel sides multiplied by the height. This is the formula for area of trapezium, right? So this you have to keep in mind, and we will use this formula to find the area of triangle. Let us see how. In this figure, you are having three trapezium. Can you able to identify three trapeziums in this figure? One is this one. This one. What is that? A, B, F, E. Okay. Are you able to see the trapezium? How it is a trapezium? Because these two sides are parallel. Which are parallel? A, E and B, F. These are parallel. And what is the height? Height is the distance between F and E. Okay. The distance between F and E is nothing but height, and these two lines are the opposite parallel sides. Okay. Now, if we know the length or the distance between AE and BF and FE, we can substitute in the formula for area of trapezium, right? Okay. First of all, why we need to find the area of trapezium instead of area of triangle? That I will explain. Because the area of triangle I will remove this red line. Why we need to find the area of trapezium? Because this one trapezium, here the another trapezium, second trapezium, the third trapezium is this, right? Now, why we need to find the area of trapezium instead of area of triangle? Okay. The thing is, the area of triangle, right? If we find the area of trapeziums 1 and this trapezium 2 Okay. So finding area of ABFE and AEDC, right? The sum of the areas of two trapeziums will give the area of the whole picture, whole geometric figure, right? Now to get the area of ABC, the triangle ABC, just you find the area of two trapeziums and from that value subtract this portion. This is another trapezium, no? Okay. Find the value of this trapezium. Okay, subtract from the areas of those two trapeziums, then you will get the area of this figure. I hope you have understood. Okay, I will explain once again. So to find the area of triangle, our approach is first to find the area of trapezium ABFE and AEDC. So these two areas, the sum of these two areas will give the area of the whole figure. Whole figure means ABFDC, right? The whole figure. From that value, if you subtract the area of trapezium BFDC, okay, then you will get the area of triangle. The left out portion is only this much, which is nothing but the area of triangle ABC. Now we will start finding the area of trapeziums one by one, right? So area of triangle ABC is nothing but, first you find the sum of area of trapezium ABFE, then area of trapezium AEDC, then from that value subtract the area of trapezium BFDC. So what you will get is the area of triangle, right? Now we will find out the area of trapezium one by one.